Good morning, everyone. Myself, Archana, PGT Physics, Vidya Lakshmi Senior Secondary School. And today we are going to discuss one of the very important topic in your 12th standard physics, especially from ray optics. And you know about two optical phenomena. What are they? We are discussing in ray optics. One is what? Reflection. Light undergoes reflection. The second one is what? The light undergo refraction. Yes. And in refraction, what is happening? Actually, when the light is passing from one transparent medium to another transparent medium, entirely the path changes. The reason behind it is the change in what? Refractive index. Okay, that's what we are going to discuss next. Okay, so today's topic is actually how to find refractive index of a liquid using convex lens and plane mirror. Very simple setup, and using the theoretical concept and experimental concept in combine, we are going to find out the refractive index of any liquid. For example, now I am going to take water. Okay, instead of water, you can take any liquid which is having a different refractive index. Very simple setup. So here we are going to combine some theoretical concepts as well as the practical concepts together. Okay, let's go to the first topic. What are the laws of refraction? Okay, what are the laws of refraction? So before that, we should know about the change in the path of light, right? So look at this one. This is what? The incident angle. Here you can see this is the angle of incidence, and this is what? One medium which is rarer medium, and the light is passing from a rarer medium to denser medium. Actually, there will be a change in what? Optical density. So rarer to denser. What is happening to the path of light? Look at this one. So always whenever you start your drawing, whatever it is in ray optics, always you have to take the angle of incidence and refraction from what? From the normal only. Then only you can get the values. Okay. So from the normal, this is what? Angle of incidence. Okay. So what is this? This is called what? Angle of refraction. That means refracted ray is making an angle with the normal. Okay. So already you know, you already studied in 10th standard. So what is the law of refraction? First law of refraction is what? The angle of incidence, angle of refraction, and normal at the point of incidence all lay in the what? Same plane. Okay. Because you know about plane, isn't it? There are infinite planes like this, like this. So here we are talking about this plane alone, this XY plane, right? So now any ray is coming out of the plane. So that's the first law. That makes the first law of refraction. What is it? Angle of incidence, angle of refraction, and normal at the point of incidence all lay in the same plane. Very simple law. The second one is having more mathematical equation for that, isn't it? And this is very important formula. Lot of numericals from this as well as prism and all. Lot of numericals are there based on this formula alone. So it's very important for you to understand how to apply this law. What is the second law? Second law is nothing but Snell's law of refraction. So it's nothing but Snell's law. What Snell's law says? Snell's law of refraction. Okay. So what Snell's law says means sine of the angle of incidence to the sine of the angle of refraction is always a constant for a pair of medium. Okay. The medium will be like what? You know very well. Refractive index will change. So sine of the angle of incidence to the sine of the angle of refraction is always a constant. Do you know what is the name of that constant? That's called what? Refractive index. Okay. Refractive index is a unique property in the optical world. Okay. Each and every object or substance is having different what? Refractive indices. Is that clear to you? Suppose the refractive index of water is 4/3. The refractive index of glass is what? It's different, 1.5. Glass also having different type like flint glass, all these things, crown glass. They are having slight variations in the refractive index. I hope it is clear to you. Refractive index is a unique property of the material which is like density for a material which is very much unique. I hope this is clear to you. Okay. So what is this equation? Refractive index. And here I represented with a small letter n. It's not necessary you are always representing it with the small letter n. There are other symbols also. For example, mu. N or mu, both are correct. Mu or n. What is refractive index? What is it? It is the velocity, it is what sine of the angle of incidence to the sine of the angle of refraction. Okay. Sine of angle of incidence means where you have to take the refractive indices. That's very important. Look at this one. Where the angle of incidence is there, you just take it as medium 1. Okay, medium 1. This one will be what? Medium 2. In that case, if you are taking Snell's law, you won't get confused when you are doing numericals. Okay. Sine of the angle of incidence to the sine of the angle of refraction is always what? The refractive index of the second medium with respect to first. So here the refractive index of the second medium is what? Mu 2. And the other one is what? Mu 1. So I can write it is like what? Mu 2 by mu 1 also. So mu 2 1. That's also correct. Different notations are there. So this is also what? Correct only. Mu 2 1. Refractive index of the second medium with respect to first. So already you know about some terms of this one. Already you have studied in what? 10 standards. Just continuation for that. Okay. So what is Snell's law? Snell's law says sine of the angle of incidence to the sine of the angle of refraction is always a constant for a pair of media, and it is nothing but refractive index of that particular material or medium. Okay. So what is it? Mu 2 1. Okay. That's it. Now another basic equation for refractive index, which is in terms of velocity of light, which is very simple and it's very important for many MCQs and numericals. What is it? Refractive index. What is the simple? N or mu. What is it? C by V. What is C? C is what? Velocity of light in vacuum or speed of light in vacuum, and V is what? Velocity of light in any medium. Okay. What is the value of C? It's nothing but 3 into 10 to the power 8 meter per second, and it's always constant, right? Because it is vacuum. Vacuum means nothing is there to resist that path of light. So it will be freely moving. It's 3 into 10 to the power 8. And the values are not same when the light is passing from one medium to another. It will change definitely. So that is why C by V. In the case of vacuum, when the light is passing through vacuum, what is its value? C is what? 3 into 10 to the power 8. In the case of vacuum, V is also 3 into 10 to the power 8. Both get cancelled and the value will be perfect vacuum. It is 1. Okay. The value of refractive index, mu or 1. So it's one of the basic equation you already saw in your 10th standard. What is N? N is equal to C by V. What is it? Refractive index is equal to velocity of light in vacuum to the velocity of light, speed of light in what? Medium. Hope it is clear to you. So two important equations so far in refractive index we studied. First one is what? Snell's law. What is it? Sine of the angle of incidence to the sine of the angle of refraction is equal to what? Refractive index of the second medium with respect to first. Another thing is what? Refractive index is equal to, what is it? C by V. C is what? Velocity of light in vacuum. V is what? Velocity of light in that particular medium. I hope it is clear to you. Yeah, okay. Next one, directly we are going to the experiment. Before that, theoretical background. Okay, how you can find the refractive index of the liquid using what? Only just a convex lens and a plane mirror. Before going to the theory, I will explain the setup, experimental setup, how it looks like in a physics lab. This is one of the easiest experiment if you understand how it arranged or set up. Okay, look at this one. This is what? A plane mirror. Upon that, what you are keeping? You are keeping a convex lens. And most probably you have to take what? This one only, equiconvex lens. What is equiconvex lens? Equiconvex lens means both the sides having the same radius of curvature to avoid much of the confusions. In labs, majority we are using equiconvex lens only. Okay. So equiconvex lens is there, and you can see one needle. Okay. Or pointer. Pointer is for what? Checking the value, coinciding. Okay. I will show some simulations on that, so you will understand how you have to take the reading of the pointer. I hope it is clear to you. So a mirror, and this is the equiconvex lens, And in two ways you have to do it. Okay. First one, here you can see 2-3 drops of water is taken on the clean surface of the mirror and the convex lens is kept. So this is the setup with the liquid. This setup with liquid. Another thing is, you have to remove this one, convex lens, and wipe it properly. No any water droplets should be there. Then keep the convex lens again. That will be without liquid. Okay. So two different cases to be performed. First one is with the liquid. The other one is what? Without liquid. And you have to take the values. With the liquid, what is the focal length? And without liquid, what is the focal length? So this is like combined. Liquid plus lens, combined focal length. When you remove that, what? Without liquid. Without liquid, if you are doing, it's only for convex lens focal length. With liquid you are doing, it is the combined value. So this is the experimental setup of this one. Let us see the theoretical backup. Okay, how to do. So this is the theory behind it. It's one of the important area of your exam, board exam also. Some higher level questions may come from this. In exercise also they explain, and MCQs also they used to ask this one. Okay, first formula what we are using is, let us draw that diagram again. What we have, this is the lens. Okay, so when you keep the liquid, what is happening? This is the liquid, right? So it forms a liquid lens setup. Okay, so which is the lens? This is the convex lens. This is the liquid lens. Is it clear? Okay. Another thing, what if I remove the lens? Whether the liquid lens can stay alone? Actually, the liquid lens is what? Plano concave lens. Okay. Theoretically, it is possible, but practically, no any liquid lens can stay in the air like that. Okay. So theoretically, you can say that this is one lens, and this is like what? That liquid lens. Liquid lens is in the shape of what? Plano concave. Okay. One side is what? Plane, and the side is what? Concave. Which is having what? Concave is having radius of curvature, and plane, what is the radius of curvature of the plane? It's nothing but infinity. Plane, radius of curvature is what? Infinity. So when you are doing problem, make sure whenever you are substituting the value of r and all, it should be what? Properly written. Okay. So this is what the liquid lens setup. So what we are going to do means, combined form you can get practically. Combined form, what is the focal length? Combined focal length, you can call it as F or capital F, small f or capital F, which is the combined form. Combined. And you know about lens alone? That means convex lens alone. What is convex lens alone? It will be like F1. Okay, F1 is what? Focal length of the convex lens alone. Now, you know about the combination of lenses. In the combination of lenses, each lens is having focal length like F1, F2, F3, etc. How will you find out the effective focal length or combined focal length? You can write like what? 1 by F combined. Okay, 1 by F combined, which is equal to 1 by F1 plus 1 by F2 plus etc. Here we are discussing only two lenses, right? One is what? Convex lens. The other one is what? Plano concave lens. So two lenses are there. So this is the equation. What is F1? Which is the focal length of convex lens alone. F1 is the focal length of what? Convex lens alone. And what is F2? F2 is this plano concave is there, no? That alone. Okay, it is not having an existence practically, but theoretically we can say. F2 is what? For the liquid lens alone. Liquid lens. Liquid lens alone. What about 1 by F? It's a combined. It's the combined one. So that's what you should know about it. Okay, so finally you can get 1 by F2, and here we have to apply which formula it is. You have to apply what? Lens maker's formula. What is lens maker's formula? How will you get? 1 by F is equal to mu2 by mu1 minus 1 into 1 by R1 minus 1 by R2, where R1 and R2 are the radius of curvature of the lens. Okay, F is what? Focal length of that particular lens, And mu is what? Refractive index. Second medium with respect to first means it will be like lens to air, just like that. Okay. So here just we applied the what? Our lens maker's formula. 1 by F1 is equal to mu glass, because mu air is what? 1. Mu glass by mu air minus 1, 1 by R1 minus 1 by R2. In the case of equiconvex lens, what you can say about this R1 and R2? They are same. Okay. Equiconvex lens, R1 and R2 is same. And if you substitute that, it won't be 0. Why? Convention is there. Okay. R1, one value will be positive, one value will be negative. So when you substitute negative value of this, minus of minus 1 by R1, which becomes plus. It's not negative, so 2 by R. Okay. So like that you can arrange. That is just I mentioned about the equiconvex lens, that's all. Another thing. Apply the lens formula, lens maker's formula in the expression of what? F2 alone. What is F2? F2 is for what? That particular liquid lens alone, without what? That lens. And the planar concave lens is there? No, that's alone without lens. So 1 by F2 is equal to mu liquid minus 1. Okay, because liquid is the part of lens. Lens is removed, only liquid is there. So liquid will act as the higher refractive index medium. Okay. Mu 2 by mu 1 means mu liquid by, here mu liquid by mu air will come. That mu air value is 1, right? So mu liquid minus 1, 1 by R1 minus 1 by R2 actually. But since it's a plano concave, plane is having infinite radius of curvature, and the other one is having what? R. Because it is concave, right? Concave means what? R only. Okay. Applying convention, what you will get? 1 by F2 mu L minus 1 by R. Okay. Rearrange the equation. What is mu L? 1 plus R by F2. Very simple. Okay. What is R? Radius of curvature of that planar concave. That is actually convex lens radius of curvature only. You can use spherometer for finding out the radius of curvature. Doesn't matter. It's not a big deal. Mu L is equal to 1 plus R by F2. What is F2? That focal length of what? Liquid lens alone. How to get F2 is from this formula. Using this formula. In this formula, what all things experimentally we will find out? 1 by F1 we will find out with the lens alone. 1 by F we will find out with combined. Okay. So if you know the combined from the experimental result and 1 by F1 from the experimental result, easily you can get 1 by F2. That is 1 by F minus 1 by F2. F1. Okay. 1 by F minus 1 by F1. Easily you can get what? 1 by F2. I hope this is clear to you. So what I explained is, this is the theory behind what? Liquid lens. Many of the cases children used to skip this area. But once you understand, it's not that much difficult. And in exercise, ray optics exercise also, 1 or 2 questions given from this. So in order to solve that, you should know entire theory. Okay, then only you can solve that question. I hope it is clear to you, the theory part. Okay. Now I'll just show you the simulation, how it works in the lab. Just I showed you the diagram, right? And how it works. Let us see. Let us go with the simulation. Now I'm going to show you the simulations. Just check on it. And after that, I'll show you the value, data, how to be taken. Okay. So in this case, we have 2 options here. Convex lens 1 is there without liquid. And I can change this value to with liquid also. Okay. Without liquid and with liquid case. First we will do without liquid. Without liquid. And 1 lens only I choose. And in this simulation, you can see, this is the scale. You can see the pointer here, okay? The way how you are looking at this experiment. And you can see 2 needles here. What are the 2 needles? I will explain. First needle, the original real needle, okay? And the image of this, what will happen? The rays will go down and there is a mirror, right? That mirror, it will touch the mirror and it will reflect back. So one is the actual object, another one is the image. Hope it is clear to you. This is object, another one is what? Image. So when you have to look like this, what is your arrangement should be like? you had to adjust the needle. Finally, a point should be reaching when they are crossing like this. Okay, another thing, their size also should be the same. Not only crossing in the same line, crossing means aligned in the same line. Another thing, they should be of same size. That time you can adjust the needle and fix it. After that, you have to take a meter scale to measure the values. Okay, this is the meter scale along with the setup to measure the values. Okay, that's the setup. So you have to look at this properly. When I am adjusting the value, what is happening to the needle part, you just check. First thing we are going to do without locate. Okay, so here you can change the value. This setup, you can see the size of the needle is changing. Can you see that? Size of the needle is changing. Okay. Another thing, the second adjustment is this one, the distance, the pointer arrangement is changing like this. Okay, two arrangements we can change in this simulation. First one is that distance between them and the shape. What is the size of the needle? Okay, so first I prefer this one. Okay, look at the size. Let us adjust that. Adjust so that they are in same line. Okay, you have to adjust this. Okay, slowly you adjust. Adjust it. Yeah. Adjust that so that they are in the same line. They are approximately in the same line, right? Next thing, their size is different. One is small, one is bigger. That also you have to adjust. For that, the object pointer I am going to change. It's bigger, yeah. It's almost, it should be same. Almost same. So look at the value. It's around, when it is same, almost same, what you have to check the value, 20, 20.1 or 18, somewhat the value is like 18, 18, 20, that range. Okay. So you can see the value in the pointer also. Okay. You can take it. So when you adjust, what is your pointer should be? It should be on the same line with the same size. That is your adjustment. So that time you take the value, see the value, pointer is mentioning, the scale is mentioning. So note the value. Next thing, this is without liquid. How to do with the liquid means, with the liquid, obviously the value will increase. Okay. If this is in the range of 18, 19 and all, in the case of with the liquid, it will increase beyond what? 25 something, 23, 25, above that. Okay. So with the liquid, what you have to do? You have to repeat the same. You have to adjust. See this one? Like this, same. Here also with the liquid means what? Definitely it will increase the value. Adjust the thing. Pointer, all these things, size of the pointer. See, same thing. What is the arrangement? You know, no? You have to check the value. Like this. And you have to change. Okay, so like this, without liquid and with the liquid, you can take the values like this. Okay. Okay. Now, how the values look like? Let us see. Okay, how the values will be on the table. Okay. This is the tabular column. Look at this one. Here I have included all the experimental data. First one is distance between object and needle without liquid. Okay, without liquid, only with the convex lens. Then convex lens placed on a plane mirror with the water between them. That means without water, with water, same table I mentioned. First thing, distance between the object and needle from the lens. Two distance you have to take. What are the distance? First one, when you keep the lens from lens to the needle, one distance. Okay. And another thing, remove the lens from mirror to the needle, another distance. That is what? Lens. From lens, it is A1, A. Okay. Mirror, it is B. Why we had to take means we had to take the average of the value. So, first thing is what? Convex lens placed on the plane mirror. That means without liquid. Again, through that setup, you can arrange lens and mirror A and B. Look at the value. It is around 17, 18.1 like that. Okay. Two values. Take the average of this. That is refractive index of glass is equal to A plus B by 2 from the top of the lens, and from the mirror, A plus B by 2. So we will get average on that. This is the first one without what? Your liquid. Okay. That next one is convex lens is placed and you are taking that particular liquid. That means with the liquid lens, same. Experimental setup, you have to do the same. First one from the top of the lens, next from the mirror. Take the average, you will get this. Look at the value, it's high, it's around 26. So when you are doing the experiment also, you should have a rough value in your mind. So that it should not change, okay? Approximate. On what range it comes at least you should know when you are doing these 4 practicals, okay? Now, the equation is so simple. What is the equation? Theoretically, we are explaining in one way, but this is what very simple formula. What is it? Refractive index of that particular liquid is equal to 2 minus Fg by F. What is Fg? That is focal length of the glass alone. What is F? Combined value. Okay. Both we already found. What is the value? 17.5. The other one is around 26. 2 minus this. 2 minus Fg by combined value. You will get, you know already, since it's a water, the value already know. What is this value? 1.33. Okay. So that's about the experiment. It's actually easy once you perform it. Okay. So what we found actually, refractive index of the particular liquid by the method of what? Refraction. That means we are using only very simple setup, one needle, one what? Convex lens, liquid and mirror. I hope you understood this. Okay. Thank you. So this is one of the very important topic. For more topics, you have to like, share and subscribe. Hope you enjoy. Today, I'm Archana signing off. Meet you in the next session. Bye.